Okay, let's get started with the second tech talk of the day. And it's my pleasure to introduce Professor Aniket Kate, who's a assistant professor in computer sciences here at Purdue University. He's kind of known to us as our blockchain go-to guy, so any topic that has to do with that subject, we always like to call Aniket in on this. So today's talk is about GDPR privacy versus blockchain transparency. I'm kind of intrigued to hear what this is going to tell us. So without further ado, I'll introduce Aniket.
Yeah. So hello everybody. Can you hear me at the back? Perfect. Okay. So my name is Aniket Kate. I work here in computer science department and is associated with Purdue. Typically, I work on applied cryptography, distributed systems, and as it turns out, when the blockchain came, they were the topic that I would have liked to work on, and I continue to work on that, where I try to understand the interplay between different applications as well as security privacy for cryptocurrencies and blockchain technologies as one of my key things. I also continue to work on metadata protection and other privacy issues in general by applying the knowledge from applied cryptography in distributed systems. But as I'm focusing from the title, I'll be talking about things that I like to do or I'm doing regarding blockchain here. So little bit of information from my side. I have been doing quite a few blockchain projects on asking different kind of questions and try to see how this fits in academia as well as industry, where me and my 7 PhD students and a few other undergrads, we are trying to do projects for some blockchain startups, some industrial collaboration that I have or had regarding blockchains, or in general, so in general IRPA and NSF, where we are trying to do some interesting stuff in this space. So yeah, starting to talk about the blockchains in general, I try to first associate them with this changing landscape of communication, where one key thing which I saw starting from my days is maybe in 2000 after .com boom, the businesses started to become what we can call as global. So that rather than having one local services for individual aspects like taxi, finding hotels, buying stuff, we started global services such as Uber and Airbnb and Amazon and eBay, where we have one unique interface that is applicable all over the world, and anywhere I go, I know that app can, or that application on web browser can help me to go there. However, all of them were still centralized in the sense that they were decisions how they operate are made centrally and by a board or some kind of a typical how the companies can make profit in general. And in terms of the payment space, maybe 2008 onwards, after emergence of Bitcoin, people say that can we make the governance distributed? By that I mean making the rules and following the rules. And initially it came in form of Bitcoin and several such cryptocurrencies. And then so more elaborate cryptocurrencies or more elaborate system like Ethereum. But eventually even industry saw that, hey, the core concept has value for us. And in fact, we don't need to restrict this to finance or payments, but in any asset that we wish to track could be tracked using this system. And it's a very good tool, a mechanism to achieve provenance / traceability for supply chains in general. So in fact, people are trying to employ a blockchain for everything. And I can certainly say that it's not panacea. Easily 2/3 of the current blockchain projects may result into not determine that, hey, this is not good enough or not fast enough for use, and maybe another 1/6 of them may even find out to be infeasible for all the other reasons, including regulation. But indeed, the concept is here to stay, and there are easily we are going to see significant number of use cases where this will get used for several years or for even decades in general. So the concept is here to stay. For me, when I look at blockchains, I try to associate that with 4 key parts. The first thing is obviously the blockchain, or I'll put that more like an asset database that aggregate transactions into blocks, such that these blocks are added to the existing chain in an append only fashion. So it's important word there is asset. I'm not saying transactions or payments. I'm saying anything that can be ID'd and we are concerned about its movement from participant to participant can be tracked through such database, and that's a key thing in that. An important thing for this database, it should be append only, so that the order of the thing should not change. It's important that if orders are changed, then something which is valid today will become invalid tomorrow. Then you also want to make sure that its information is available to the participants who should have access to this information. And that's the reason replication is an important aspect. You also want to make sure that only legitimate participants can perform transactions or make actions in a particular fashion. So you have to make sure that we can verify them and apply appropriate access control, as well as in the form of how the transactions are performed. And for that reason, we have to employ public key infrastructure, or in some cases just basically digital signatures, to ensure that only legitimate actions can happen into systems. And once we build such a system, we want to make sure that there is no way an individual can actually perform two conflicting actions, and for that you require consensus mechanism. And once these things are in place, you can not only use this as a storage of information, but in fact also as a mechanism where you can perform computing on this information and perform all sort of different tasks, which are called as smart contracts in general, so that it not only becomes a storage, but also an execution engine where data is not only stored but executed. In terms of the applications, I don't need to say there are Bitcoin, Ethereum, Ripple, all sort of different financial world applications emerging in permissionless setting, as we call, or public setting, or also in more permission or more consortium environment. But more interestingly, or maybe even bigger industry where it could be employed is indeed supply chain industry, where there are interesting applications and systems are emerging for tracking something like software to even something like diamonds and basically any asset that could be ID'd could be managed through this environment. And our focus today will be exactly associated with these systems here. So when we talk about supply chain and where blockchains are useful, the key thing there comes in mind is to counterfeits. How can we detect the counterfeit or anything wrong that's happening to the system and detect that faster and efficiently in terms of the cost as well as the time it takes in general. So when we look at traditional supply chain, we typically consider them to be multiple bilateral links that are joined together to form a chain. But important aspect is that although they are bilateral links, they are not transparent across bilaterally. So A will know their relation with B, but has no clue what's the relationship or how the transaction happened from B to C. When something wrong happens, they have to rely on actually explicitly making them provide their information, and when that information may come late or may not ever come, and that's the reason tracking is a very hard problem. Or that information, when it comes in a fashion so that it's modified to reduce the blame on those participants. So, and these kind of things can be directly associated when, let's say, we come across a counterfeit, or can we either prevent it, or let's say if we cannot prevent it, can we detect who actually introduced those product or component into the system. So if we can do that efficiently in terms of if I come across counterfeit product or anything, let's say the electric switch, probably want to determine where it's coming from. If we can find out that efficiently, in the sense that in matter of seconds rather than matter of days or weeks, there is a significant cost benefit that it can bring, and that's the key advantage I find, that anything that you want to track and find out where it's coming from, if you can find out that efficiently, then we can indeed solve significant problems. There are already been examples of employing ID techniques such as RFID tags and puffs which are present there, but as I already mentioned, that's a good, that's certainly an advantage thing, but it does not stop insiders or the participants of the supply chain to actually introduce fake and counterfeit products in general. And in general, as we call it, we cannot stop in academic terms, we cannot stop equivocation from the legitimate but malicious supply chain players. And that's where the key place where blockchain comes together, because it links those different bilateral links. They are joined together to form one source of information that cannot be changed later, and that's where the key advantage of the blockchain system comes in. So as an example, I'm going to how it can be. I'm going to take a project that I'm working in the automotive environment. It's a part. It's a part of the Ford Purdue Alliance, and I'm trying to understand there how can what all kind of system that we can introduce into existing supply chain for, let's say, in automotive parts, and how can then that help to detect counterfeit if they get introduced, or even how can they be helpful towards efficiently call for actions such as recalls of different components, or making sure that nobody introduces wrong components into the system. So here we just took a simple example of having a very I'll say a simplified version of the supply chain, where we assume there's some supplier who creates a legitimate part and they go to the manufacturer or OEMs as they call into the automotive industry, then to a dealer, and then finally to official repair shop, and finally that component added to an existing car. And kind of a provenance we are looking for, that if that component is right, then the car will not show any symbol. But if that component is wrong, the car itself will tell you that, okay, you added a component, but that's the wrong component. Okay, and by wrong it means that it's either an ID which is copied from a legitimate component added to a counterfeit, or a component which is not from the system, it's just added from some other shop or some other provider which may not be part of the legitimate system. At the same time, if a legitimate component is taking another part from a supplier to some other e-seller, and from the other shop to the car, if it is the right component, then maybe it's fine to add it, but it will be still good if somehow the OEM or manufacturer can keep track of happening of such thing, because it could be beneficial for them to keep track of these things so that they can stop such things from happening. So the instantiation that one can think of, or that we worked on for this project, was based on Hyperledger, where the basic idea for Hyperledger is that we take this basically blockchain environment into two parts. One is the endorsing parts, or the guys who keep the blockchain, and the other part is ordering service, which could be outsourced, whose key task is to only to take the transaction and order them, or perform consensus as we call. So the typical idea for such environment will be, whenever any such transaction to add a component or to transfer it from one player to other is added, it is sent to appropriate endorsing nodes, which will have business logic incorporated in those nodes to execute such a transaction. And those transactions, if they are correct and are correct according to the current state of the blockchain, then they'll be accepted and sent back to the client, who then send them to the ordering service, and then ordering service collects such few transactions for any ordering period, and this service could be an individual node or distributed, and then once they have done with the consensus, those order transactions sent back to the blockchain, where it could still happen that some transactions are ordered differently, such that some of them can become invalid because of the read and write priorities that they have. Accordingly, some of them could be invalidated, but eventually a valid set of transactions are added to the blockchain and are available to all the endorsing peers in exact in a fashion, so that all of those who are functioning correctly will have those transactions in exact same order. So in our situation, the idea will be each of those nodes we saw on the previous slide will introduce their own endorsing peers, and appropriate transactions will typically associated with them. For example, let's say a particular auto component is going from supplier to manufacturer, then it has to be validated by an endorsing peer offered by manufacturer and as well as by the supplier, so that it's not possible for any of them to trick and introduce fake components or wrong information into the system. The important thing is that for such a system is that, let's say now we're talking about this dealer, that guy has nothing to do with a transaction that is happening between supplier and the manufacturer. In that case, such a transaction will not go to this dealer. For example, let's say this endorsing peer 3 is a dealer, and they will not have business logic how to process this transaction, and will not also know that. So that's the reason this execute and order and then validated process allows them to collect information, so that they can also become a third party in terms of conflict. But at the same time, they don't need to execute the transaction. So this validation, they perform validation, but they do not actually perform the execution of the transaction in general. Okay, that's the core idea, which makes this approach interesting in terms of making sure that we have nice access control at the same time allow to have the information available to all such systems. So what kind of issues that one can see? So this whole hyperledger based system has provided a nice bootstrapping mechanism, and there are all sort of different projects that are emerging in the industry. For example, that IBM and Merck is working on to get a blockchain which works across different shipping environment. Walmart has something going on in similar things, so is Kruger and all such systems. But the key thing that is emerging in this case is what is known as IP problem, which basically just asks that who runs this endorsing peer. The guys who run this endorsing peer have access to the information, while if you do not run an endorsing peer, you do not have access to the information. So the question is that who all run these peers, and that becomes a challenge. In my example, I mentioned everybody can run this peer, but in fact that could be a challenge in general in many scenarios. And that brings us to, in general, what kind of issues that we have to deal with in scenarios. So the first thing is what we can call an IP protection or access control. And another important thing is also metadata privacy. So I like to focus in this talk regarding access control and link that to the GDPR engine. So here is the example I'm showing, as I already mentioned, that we will make sure that in our example, let's say we are saying add airbag, then only a supplier can provide an airbag and add that to the system, so it's only available to supplier. It's not even available to manufacturer, as I'm showing here, or any other parties. Similarly, when you are transferring airbag, it could be applicable to appropriate parties which are present in such a system. So, but then when we move on to have a scenario where, let's say, we consider the supplier, OEM, and dealer, and then going to the that information going to the car in general. What we'll do here is that we added 3 different endorsing pairs for each of them. But let's say in our traditional, in our typical scenario, there won't be one supplier or there won't be one OEM, but there could be different such players which are present. I mean, where there could be easily hundreds of suppliers, there could be tiers of those, or even types of dealers, there will be dealers all over. And the question is that what's the infrastructure that we can provide for such endorsing peer? The simplest solution is that each of those entities also introduce their own node into the system. And now any transaction that involves them in a traditional supply chain, appropriately we need to add a component for those. However, the challenge will be that it may not be always possible for small dealers or suppliers or any such tier 2 suppliers or such small entities to introduce a node into system. Or maybe some of the big players find that to be conflicting in general, that the whole blockchain is available to such small entities. So that introduces an interesting challenge, that how can we tolerate and introduce such small scale players or large number of players in the system without introducing node for each of those into a chain. And if we do not add into node to chain, they will be worried about IP or the protection for their own information, or who is taking decision on behalf of them. On the other hand, if we introduce node for each of them, it could become a challenge in general in terms of the scalability of the system. So that's certainly something that is an essential in this environment. It's also related to the typical GDPR issues in this space. So for some of you who haven't heard about this, in Europe they have been working to have a new data protection regulation for several years, and the plan I think got finally passed in 2016 with a lot of negotiation between privacy advocates as well as between the different industrial players, that what looks to be a good measure that we can introduce into the when a user data is collected by the industry, and how can we make sure that users' privacy is protected into these scenarios, while at the same time ensuring that the businesses, the interest that is associated with business, that businesses have from the data are also protected simultaneously. There are several basic principles that are associated with this, but for us the two key things that is associated in this environment is, one is the accuracy. So you want to make sure in this environment that if an entry that is added or that is taken for me or the individual or any organization, for example, if an entry is added on my behalf into a particular data that is collected by industry, and if it is wrong, then it should be possible for me to correct it. Okay. And another thing is the storage limitation, where you want to make sure that a particular entry, when it is added for my entry is added in such a system, that eventually it is removed from the system when the use of that is over, or maybe when a particular time that is already decided for that, let's say 1 year or 2 years, that's over, and after timeout, that information should no longer be available to them. And as it turns out, those principles indeed may look as if they are going against the blockchain concept in general, because the first thing is that they, as I already mentioned, that it's assumed to be an immutable structure, so that when you add something to blockchain, nobody can change it. Okay. And on the other hand, it's also the structure, once some information is added to the blockchain, now you cannot remove that as well. So changing is also difficult or not possible, and removing is also not possible. So that's the impression in general people got, and there is indeed an impression I come across when I talk to people in industry, that when they want to act, then when they look at GDPR and blockchain, they find those concepts to be opposite of each other. And because many of the organizations that we have, and I guess some of you will be agreeing with me, that they have presence all over the world, including Europe, when they want to roll out a solution, and if they cannot incorporate that solution into the business that associates the Europe in general because of the system, that solution just probably cannot work. I mean, if you have a supply chain and somehow that part goes through, let's say, Europe, and all of a sudden you cannot add any entries in that scenario, now all of a sudden there is a lack of information, which will result into significant issues in terms of any usefulness that we can get from such a blockchain concept. So that's the reason it's very interesting to consider the interplay between these two, and I'm going to spend few minutes of my talk for last 10 minutes focusing on those aspects. So we can actually look at those concepts into three key rights that are typically associated with the GDPR: right to erasure, right to ratification, and right to object to the processing. So right to erasure is exactly the first, the second one that I mentioned, is that if something is added where it's my data and it's collected by as they call as collector, here basically those endorsing peers are going to become collector. Now it should be possible. It's my right to actually remove this data for a particular reason. Okay, it could be just basic timeout, or maybe if I get a court order or something like that, or some other reason which is defined by regulation, I should be able to remove this information. The second is right to ratification or rectification, where the aim is that when some information which is present there which is wrong or should be changed, then it should be possible to change that information. Okay. And the third thing is right to object to processing, where maybe you associate that for a particular usage you find your information should not be used, then you have right that you can specify that and your information is not employed for that purpose. For our discussion, because we are not talking about individual users, but we are talking about typically small organizations, small or large scale, and because they are part of a supply chain system, and this is a traceability mechanism, in most typical scenarios, we'll be only focusing on right to erasure and rectification. A right to objects maybe is already given in because you yourself also want to become part of the traceability system. So at least it could be inherently employed into environment, but I think the focus in this environment is typically associated with right to erasure and right to rectification. And the challenge is that how can we incorporate and introduce changes to the blockchain environment to work with that. So the first thing is, if we work with something known as public blockchains, or what typically is like examples such as Bitcoin or Ethereum, at least in current form, it's not possible at all. As we say, once information is there, it cannot be changed, and it's certainly something which is just not possible with the way they're currently employed. But that doesn't mean that we cannot change those systems to make it work. or if we define Bitcoin or a private version of Bitcoin or private version of Ethereum, indeed they could be modified to work with this system. And what we are going to see indeed is 4 key issues that I find while going through these systems, and how we can work with, how can we introduce cryptographic solutions to overcome those issues. So the first issue that typically associated in that space that I come across is one which is associated with appropriate safeguards for the transfer outside EU. When this information from European Union, which is transferred from one subsidiary in EU to, let's say, US or elsewhere, how to make sure that the information is safeguarded in that scenario. Again, in public blockchains, it will be a tough challenge because there are no, there may not be legal boundaries that are well defined. But at least for permission blockchain scenarios in general, even basic contractual clauses and corporate rules could be employed and used there. However, we find that even cryptographic solutions such as encrypting or committing to this information could be employed, where the idea will be that the data will reside in general on all the associated players. However, the way to encrypt it or way to actually unwind or decode that typically may not be always available to every participant. So although data may be available outside, but in a fashion so that they cannot see what's actually the data values which are present in this scenario. Another issue is that a blockchain can contain personal data, and personal data cannot be stored for unlimited time. So the idea is again just similar as we saw with the encryption or here, is that you will never store to make it work. The solutions such as Hyperledger or other blockchains could be modified so that we never store the information in plain text, but it's always stored using cryptographic commitments or committing encryptions, such that now again the thing is that the data will be always there in this particular fashion, but the way to actually decrypt it, like the key that is required for encryption or the randomness that is associated with commitment, can be destroyed with the exact same rules that companies are already employing towards making it work in a centralized setting. And now, when those 2 measures are available, it's possible to make sure that for the time duration or timeout that is specified, when those keys or those values are removed, it's no longer could be accessible through this mechanism. It may require that to make it work in a fashion when the data could be accessible not by individuals but also as in the form of a computation which goes across multiple parties. There are also solutions available for multi-party computation. A core cryptographic concept that could be employed towards working in that. Another thing is that is request for erasure, where you want to make sure that the elements are erased after a particular time, and similar to the second scenarios where a request comes, there could be you can add queries or you can add the instructions that goes from clients to the blockchain, so that through those blockchains, not only based on time but also based on the request that is made by the users, we can introduce erasures by employing same things, and basically the erasure of the elements or the keys appropriately could be employed that, and the keys that are employed either for encryption or for decryption or verification appropriately in terms of encryption and commitment can be destroyed, so that now we can no longer associate information with ourselves. The final thing, which is I'll say requires significant change, is what is known as request for ratification, when you want to change some entry, so that the entry is still present for a user but it's now changed or it's ratified. And there the interesting solutions could work in terms of what is known as retractable blockchains. And it's still emerging concept. There are no perfect solutions which are available, but there are interesting solutions that are emerging in academia, where the aim will be now, it is possible for some players or a bunch of players to become what they can call as ratifiers, so that when the request comes, and as long as we trust them as a group, not as individual but as a group, it is possible that they can change the entry so that the same entry or same what we can call as committed entry is now associated with some other information. So I'm not changing the entry in the blockchain, but its interpretation could be changed the way it is employed into the blockchain, and that's certainly possible within concept called, I mean there are several ideas, but the key idea which is known as called Chameleon hash functions. So it's a hash function, but it's Chameleon so that you can associate the same hash value or same output to some other input, so to any input of your choice if you know an appropriate key. So such concepts are getting built at least academically, but actually bringing them so that they can work on the state-of-the-art permissioned or permission-less blockchain that are employed is still a challenge, and it's worth exploring. But the message that I want to give is that all these problems, although which are present with the when we look at the transparency offered by blockchain and when we look at the privacy rights that are typically associated with GDPR, it is possible to overcome those solutions. We have to modify blockchains a little to make them work, but that's certainly something which is doable, and interesting solution could be built even using the cryptographic knowledge that we possess today. So yeah, with that I'm coming to the end for my talk. If you want to know more about research that we are doing, go to our webpage and you'll be able to find out projects that we're already doing or in general space regarding associated with the blockchains and its privacy. Okay, thank you.